and how to navigate the file system. And here, this section will be a high-level talk about the Linux file system concepts. I will not do a low-level description of file system types. So you may ask, how do I list my files? How do I create and remove files and directories? How do I copy and rename files and directories? So the learning objectives here are: how do you navigate the file system? You learn something about files and directories. How do I find which ones I have? What are paths? How do I create and delete files and directories? How do I rename them, copy them? There will be a brief introduction to permissions, and you'll learn about some of the more common flags or options and arguments to shell commands. And also there is something called tab completion, which can make it much easier to type or to work. This here, I will just open it in a new window. Let's see if I can click it. I have used a command called tree. Tree exists on some systems, not on others. If it's your own Linux computer, it probably exists. Otherwise, you can install it. If it's on a remote system, one of the HPC centers, it will exist on some of them and some not. And they have a description of how you can install it, including as not root. But in this case, I'm just using it to show how the file structure looks on, in this case, a desktop computer. And there are some directories you will often see. There are user lib, and user lib 32 and 64. There's user bin, which has some of the system-related binaries. And there are also some here which has libraries and 64-bit libraries and things like this. There will be a scratch directory, a temporary directory, which can be used by the system or by you when you are maybe compiling something. There is /opt, which often has user installed stuff. And there is home, under which are the home directories. So this is a typical way the system will look if it's a local private desktop that runs Linux. If it is one that on one of the HPC centers, if you ran tree at the top root level of that, you would get an enormous output because there is, for instance, a lot of directories under home and other things like this. So that would be annoying. And one thing to pay attention to is that the root is called slash. That is the top level or the root level, the highest level. And there are also some symbolic links here, and I will talk more about those. But briefly, I can say that symbolic links are used for two things. That is, it's easier. Maybe you don't want to type a long path in order to get to some directory, so you just create a symbolic link. And another way is there may be some program you install which has hard-coded paths, and maybe you can change it in the program, but it might be annoying, or maybe you can't because it's a binary. And in that case, you can make a symbolic link so that the program actually sees the path or the directory in the place it thinks it sees it, and even though it's actually then sent to the actual location. But I will talk about that later more. But this is what these are. And I should also mention that the path or path name, that is the representation of the location of a file or folder or directory on a computer file system. And I have tried drawing here how part of this file system looks. So the root of the directory structure, or the file system on Linux or a shell will look like this. Under that, you have these various other directories that I just mentioned. And here is the home one. So that is where the user directories are under. And here are these binaries and libraries. So the path to, for instance, this bin directory would be /user and then again a /bin, because this character, the slash, it is used for the root directory if it's in the front of a file or directory name. If you see it inside of a path, it's just meant as a separator. So the address or the location is /user /bin. If you are not root, as I said, running tree in the root directory will give you a huge output, and I can show you that briefly. So I will just run tree here, and you can see it outputs a ton of stuff. So there's no good reason to do that. Anyway, this is another way of showing the home folders. I have made a drawing just like I did earlier. And here you can see it's called /home/ your username. And these are usernames of some random people on Tetralit. Almost random. And your home directory, the path to that varies. If you're on Tetralit, it's /home your username. If you're on something like Kebnekaise, it's /home, first letter of your username and your username. On laptops or desktops where you have installed Linux yourself, it's probably in /home /username. And if you want to know the path to where you are, you can always do pwd, print working directory. It will show you where you are. You can see I changed to this directory here. I say pwd, it tells you this is where you are. It's very good if you feel like you have gotten lost in the file structure. Just type pwd and then it will show you where you are. And yeah, you can try that out yourself. You can try go into this exercises directory that you have downloaded. See, I have this one here, so I go into exercises and then I say pwd. I now have this long path because I have the path to the project directory, to my working directory on the project storage, and then under the exercises directory. And as you have seen me do, I use cd to change directory. So just remember it as C for change and D for directory. If you just type cd, you go to your home directory immediately. And the home directory has an environmental variable that is called $home. And that is useful because you can use it in the path when you are addressing it, for instance, in a program, and or to go to it in another way, but otherwise cd always goes to your home directory. And you can see that because I say pwd, I'm in my home directory. If I want to change to some directory, cd, I would go there, cd, I can go back to this project storage. And now I'm there. If I say cd and a space. The space is important. And 2 dots. I go up 1. CD, 2 dots. I go up 1. And if I say CD and a line, I go back to the directory I was just in. That can be useful if you, for instance, had just typed this line here. You went there, and then you thought, oh, I need to go to my home directory and check something. So you go to the home directory, and now you checked it. You want to go back to the project directory. You don't feel like typing this long thing. So you just say CD and a line. Always a space, and then where you want to go. So that is useful. And this here shows the structure of the exercise directory that you got after extracting the tarball. And this shows how it would be on a Linux computer that is, for instance, your home machine. So you would have home, $home, which is /home/ your username, and then exercises. There are these directories that you saw here. I will just go to them so you can see them here as well. There is the my test here, patterns and scripts. Those two here were the ones I just created, so they are not shown here. But this is if you just extracted it. Under my test here is test here 1 and 2. Remember, if you're on Tetralit, instead of $home, it would be /proy/Linux intro/users, your username. Yeah. And if you are standing either in your home directory, if you put it there, or if you're standing in the project storage, if you put it there, then do CD exercises to go into the exercises directory. You can change to testdir1 with CD testdir1 and CD to quickly go back to the home directory. And you can, of course, give a long line, a long path to go directly to a subdirectory. And if you want to go to it from anywhere, you would, if it was in your home directory, do like this. Otherwise, you could write cd proy Linux intro, users, your username, exercises, and then what it was called under it. So let's go into my test here, and then 2. And then you go to this place here. So you can put in a full long path to go to somewhere. And these are called full paths, absolute paths. But if it's a path that is relative to where you are located, it's called a relative path. So this is a full path that gives the location on the file system irrespective of where you are located. But if you are located here and you say cd testdir1, this is a relative path. It is relative to the directory you are in. So let's go on to listing files and directories. But first, I would like to give you like 1 minute to try these things out. Just try change into a few of the directories and try use the cd space 2 dots to change back to the directory above it and things like this. And cd to go to your home directory. So try some of these commands. Okay, I will continue talking about listing files and directories with the command ls. And it means to list files. And if you just give the command ls with no flags, as you have seen me do here several times, it will list all the files in the current directory except for what are called hidden files. Hidden files are often configuration files. And you can give flags or options. Options are often called flags to these commands. And then you can also give them on a directory. If you don't give a directory, it will work on the current directory. Some examples are, you could say ls/, it will list the contents of a root directory. So let me do that. See, this is how the root directory looks on Tetralit. If you say ls and space and 2 dots, you will get the content of the parent directory of the current one. Like this. And if you say ls and then a tilde, then you will get the content of the home directory. Because tilde is another way of saying the home directory. And ls and a star will list the content of the current directory and subdirectories. So I will go up one and type ls star again, because then you will see how it looks. It lists that my testdir has 2 files. It has 2 direct subdirectories, and the 2 subdirectories have some files that are also listed. Some commonly used flags or options are these. I will not go through all of them, but -a will list content including hidden files and directories. There are none really in this directory I created here, but if you do ls -a, it will show the 2 dots for the directory above you and the 1 dot, which is the directory you are in. The -l option lists content in long table format. So I will try to do this. It looks like that. It will give you permissions, owners, size in bytes, modification time and date, file directory name. And if you say ls -t, then it will list content sorted by last modification date. I should probably add L also, so I get long format. And then you can see that it is listed after with the newest one first. You can reverse the order with an R. Then it gets the oldest ones first. Newest ones first, sorry. I'm slightly sleepy. -LH, if you do that, it will add an extra column to the above representing size of each of the directories. So let's try to do that as well. And here you see it now gave a human readable size. It actually showed the size before, so I'm guessing that is the default on the Tetralist system. But there are several other flags that you can use. And one way to get more info is to use ls --help or man ls, and that will give you some suggestions. You can see here. It will tell you some of these options. And man ls will tell you even more, and you can go through that. And those are generally a good way of getting information about a command. So the command --help may give you info. And doing man and the command man for manual will also give you information, and that is common on Linux system, that this is a way to get info on which options are there and how can I write things well with this command here. And you could do it with man ls, man mkdir, or whatever it is you want information about. And well, here is an example with an output for a few of the flags for one directory that has 2 subdirectories and some files. And I basically went through these a moment ago, so you can do them yourself as well if you want to. And I guess we can take a couple of minutes and you could try to do this as well. So I think that's a good idea. So let's take until 9:55 so that you have a chance to try these examples in the exercises slash my test year, because that will give you some useful output. So I will continue to go to change mod, how to change permissions. As you saw when you used the ls-l, then there are some things here at the beginning, and those are permissions. And the permissions here are in several groups. First, there's one bit here, which is for if it's a file, if it's a directory, if it's a link. If it's just a line like this, then it means it's a file. If it's a D, like here, it's a directory. And if it was an L, it would be a link, a symbolic link. Then there is a group here of 3 bits, and that is for the user. And then there's one for the group, and everyone is in a group. And in this case, this is a group Linux intro. And then there's also a group here for everyone else, others. So this file, my file.txt, has readable permissions for me as a user. It also has readable permissions for groups and for everyone else. It has writable permissions, write permissions for user, for me, the owner, but not for anyone else. This test dir 1 and 2, it has both read, write, and execute permission for the owner, for me. And it only has read permission for, sorry, it has read and execute permissions for others and for group. And S is for search. It can execute something below it. So you will have 10 bits, or what we should call them, like this here. And there are ways to change these permissions. If it's for the owner, you can change it with plus and then either read, write, execute. So let's say I have this file, my file. I want to change the permission so that I can execute this file. And that is a common thing you want to change. So you say plus X on my file, the text. And let's see how it looks now. You can see now, before I had read and write access, now I had read, write, and execute access. If I want to give some people in my group access, I take the same command I had before, and then I put a G in front of it for group. And I do like this. And then now people in my group can execute it. I notice I forgot to give them right to actually read it. They may not need to, but because maybe they just need to execute it. But it's a good idea to also Give readable if you want them to be able to edit it. Or maybe you don't want that. Maybe you don't want to risk that your colleague is changing it. But, let me try and do this. So these commands are each time adding a permission. And see, now both you and the group have all the permissions here. But what if you want to remove some of these permissions again? Well, then you do change mod, CA's mod, space, and then you say minus. And in this case, it was a group, so we put a G in front of it, and then a minus, and then we say W, because I don't want anyone to make changes to my file. And then now the write permission bit is changed and it's gone here. You can do the same for the others. You can add read permissions, write permissions, execute permissions, or you can remove them. You can add any on all of these, or you can add all of them at the same time, or remove all of them at the same time. And that is quite useful, especially the one for executing a program or something. You will very often need to make changes so that you can do that. And well, try and do that now. Yeah, while I'm also playing around with it. And if you type -R, then it will be recursive, so you could do it to a directory. So if I just show you what is in testdir1, it has these files, but I could say change mod -R and then testdir1, and then this here, that will make changes to all the files in it. And then what would I want to change? I would want to make those files executable. So I will say +X. And looking at the files, I see there's actually only one of them maybe I want to make executable. So I will change that one, file2, like that. And then it says cannot access X because I put it in the wrong place. It is important with order. Like that, because I didn't want to change all of them. I'm just changing one of them, so I don't need the recursive. That's true. Okay. And now I will instead show you how it looks. As you could see here before, this one did not have execute permissions. And sorry, I needed to look at that directory. And this one now actually does have execute permissions. And I actually want to be able to read it as well. Because what I did here when I wasn't thinking, I was actually removing the readable permission to it. And it needs to be a capital R because I was not remembering correctly. See, now it is read, write, execute on this file. And another thing to notice is that on many systems there will be color coding. So this will show in green on tetralit when it is executable. That makes it easier to see when you are listing the files. So if you wanted to do it recursively, you would say -R instead on the directory. And then whatever you wanted to do, read, write, for instance. And one thing I also want to show here now is that if you push the arrow up for commands, you will scroll through the commands that you have given before, and that can be useful and quick if you want to redo something. Maybe you know that you want to go back to some place and you know you typed that path just previously. So just scroll up through the commands and down through them with arrow up and down, and you could try that also. Another thing is the tab completion, and that means that if I am starting to type change mod, I for instance just type CHM and press, then I can press the tab and it will autocomplete. And that is often useful if you're going to type a long name like testdir1. So write the first letter, hit the tab, it will autocomplete. If there are more options, it will autocomplete up to, but not including the options. If you hit it one more time, like that, then it will show you which options are there. So that is very useful. So how do I create and remove directories and files? That also is something that you need to do. And I will just write a command that is called clear, and I use that to clear the screen because now I want to start working again and I don't want everything else on the screen to be in the way of seeing the things I want you to notice. So I will go up one so that I don't make changes to my testdir patterns and script. I'm instead going to create a directory again, like I did here with mkdir, and I'll just call it new dir. And you can see it's there. And if you wanted to create a subdirectory and a directory at the same time, you could use mkdir and space -p and space, and then you give the directory you want to create slash a subdirectory you want to create, and you can do that immediately if you add this option. If you want to remove a directory, you need to add this option -r. So let's say I want to remove this new dir I just created. Like that. You can see if I'm trying to remove a directory without giving the -r, it will complain. I cannot remove my dir, it's a directory. But if you add -r, you can. It is possible to add a option called -f. That means remove without asking. At some places that is the default, but otherwise you can add it. It means it will remove not just the directory, but also all subfiles, subdirectories, and files under it. It's useful, but also dangerous, so be sure that you know what you're doing. And you could try and also create a directory and remove it, just like I just did. In general, for files, when you create files, you do so with an editor. And we will talk about editors in a little while. But one way of creating an empty file, as I mentioned earlier today, is with the command touch. So you could just do touch file, like I did before, my new file text. And you now have it here. To remove it, you just do now I'm trying to see if I can just autocomplete by pressing tab. And I could because there were no others with that name. So I just remove it. And I can see that Tetralit has the option -f. as default, which means that it will not ask before removing. In some places, it will not have it as default, but that means you don't need the flag or option -F. So I have some examples here that you could try. And as a reminder, I tell you here which commands you would use in order to, for instance, create directories, remove directories, and things like this. And try simply go through these examples here. And I will do that as well. And I will type slowly. So I will create a directory. And I will change into it. I'll just show you there's nothing in here. I'm going to create a directory testdir1. And now I will push arrow up and I will see that I can just make changes to the previous command. And I will do arrow up and I will make changes to the previous command. I have now created 3 directories. They are here. I will remove testdir3. I don't need the -F, but I need the -R option. I remove it. I will try go into testdir1. I will create some files there. And I will use arrow up to make changes to my previous command. So simply creating some files without anything in them. And now I have a bunch of files. And as you can see here, they are all empty. I will try remove one of the files. And file 5 is clearly unique, so I can just push tab to autocomplete and remove it. I will go back up 1. And look what I have here. I also have testdir2. I'm going to go into that and find I have nothing in that one. So go back up again. And now it looks like this in my exercises directory. And I will go directly to copying files and directories. So the command to copy files and directories is cp for copy. So imagine you want to copy a file into a directory. You do that with cp, and then here I have a file, my file, and I copy it into my own test directory, like that. And let me now do ls my own tester dir, and you can see the file is now there. I can also copy a directory into it. So I could copy my test dir into my own test dir, and you'll see what it says now. It tells you that you have not specified -R, and that is because there is content under it. So you need to specify recursive if you want to copy the content that was under it as well, like that. And now that one is copied there, and it's also still here. because I copied it. And this is, well, the same thing that we just did. But you can do these tests if you want to later, because we are in a little bit of hurry. So, but this is basically what I just showed you here. If you want to rename files and directories, then you use the command mv for move. You move the file 1 to file 2, for instance. So let us look here. Let us go into my own testdir. Let us go into testdir1 because we have some files there. And I'm now going to rename file 1 to be file2.txt. As you can see. And if I want to rename it something that already exists, for instance, I want to rename file2.txt into file2.sh, you can do that. It will overwrite. So that is one thing to be very careful about. You can also rename directories with the exact same command. I will go up one and show you. I will now rename my testdir to mkdir. It is renamed. And if you don't want to risk overwriting something, you can use the command -I to move in order to make it ask or make it complain if it already has a file with that destination name. And in some cases, it will do so automatically. It depends on how it is set up on a system. On Tetralit, it is set up to just let you rename without asking. If it was set up to complain, you could use -F for force, and then it will not ask. So let's try do this exercise here. You can type along. Well, I will go back into my own testdir. And then I will create 3 files with touch. And I will just create them quickly. So I will use arrow up and only change the number on them. I have now created 3 test files. I will also create a directory. And I will create a subdirectory. And then I will create a file inside this subdirectory. Inside the directory, I will go to the directory. Here there are no files. There's only the subdirectory, and I will create a file here with touch. I will move it to this subdirectory. New file for text. I copy it to the subdirectory. That means it's still here, but it's also under subdirectory. And I will now rename this directory subdir to my subdir. It is renamed. I can try removing my file here. And I can also remove my subdirectory. And I will see that now it should complain. It does. I will go ahead and add a -R in front of it, like that. Now I'm allowed to delete it. And as you can see here, there's nothing in that directory. And remember, check with pwd if you worry that you are located in the wrong place. It's always good to check before you go ahead and remove things or create things. Make sure you are in the right place. And just as the last thing here, before I move to next section, I will just mention symbolic links as I talked about them briefly earlier. When you read about them online, you will see they can be called symlinks or soft links, and they are a pointer to another file or directory. And they are useful because maybe you don't want to type a long path, or maybe you need, as I mentioned, to install a program that expects a file or directory to be in a specific place, for instance, a library. And that means that you don't need to make a copy of the library in the new place. You don't need to rename it. You can just make a symbolic link which has that name. And I will go to my home directory on Tetralit. I will use pwd to show you I'm in my home directory. I will check what I have here. I have a project storage link. I'm going to remove it. And now I am going to create one. So I'm going to say ln for link, -s for soft, and then I'm going to give the directory path, the full path, to this project storage. If you don't have project storage on the place where you are working right now, you can just make an example where you make a soft link to some other directory. For instance, to the lowest subdirectory under the exercises directory, just as an example. So ln -s, and then I'm going to put in this full path here, and that goes to my project storage. And I'm going to make sure I have it in my home directory by doing $home. I could also just have used pwd first and checked I'm actually in my home directory, but this means I can make it anywhere. And I will call it my project. And now let's do a list here. And you can see the very newest thing I created. This is this link here. And I will show you I'm in my home directory. I'm now going to do cd my project. And I am actually here in the exercise, just above the exercises directory. So I'm in my project storage. There's one thing you will notice, which is that it will now tell you that you are actually in a directory under your home directory. Of course, it is not completely true, but it's since this is now also called my project, it's fine. And you are in the right place. You are in your project storage here. So this is how this works. So the key points here were your home directory is located in /home username or /home first letter of your username. And remember the slash is at the top level means that it refers to the root, and it is also a separator. Your home directory can be addressed with the environment variable $home. pwd print working directory is useful to determine your path and current location. You change directory with cd and the directory. Just giving the command cd takes you to your home directory. ls is used to list files and directories. You change permissions for files and directories with chmod, change mod. You create a directory named dir with mkdir. You remove a directory named dir with rm -r dir. Remember the -r, recursive, so it will also remove stuff under it. It will complain otherwise. You can create an empty file with touch in the file name. You can remove a file with rm and the file name. The command to copy files is cp. The command to rename files and directories is mv. Symbolic links are pointers to another file or directory.